Section 6.1, we're going to talk about differential equations. Anybody know what a differential equation is?
An equation that involves differentiation to solve.
If this is an equation that involves derivatives. For example, a very simple differential equation, y prime equals 2x.
Doesn't Corning have a class with all differential equations?
We do. We offer Math1620, which is called ordinary differential equations. You will probably be taking that 1 year from now.
I have a friend who does that right now.
Who's that?
Jesse.
Jesse Grossman?
Yeah.
Yeah, he sits right in the front row. I happen to be teaching differential equations this semester.
Yeah, he told me he got like 1 point off on his test. It kind of bugged him a little bit.
Yeah.
We talk about math.
All right, so anyway, this is an example of a very simple differential equation, y prime equals 2x. What do you think the goal is when you have a differential equation?
Solve for y.
Yeah, you want to solve for y. You want to find a function that makes this equation true. Your goal is find a function, or more than one, sometimes there's more than one, that makes the equation true. Well, can you find a function that makes that differential equation true?
X squared over 2. Y equals x squared over 2.
I don't think x squared over 2 is the right answer, but you're close.
Y equals x squared.
Just y equals x squared.
Oh,
Because if I take the derivative of that equation, I would get y prime equals 2x. So y equals x squared is indeed a solution to that differential equation. Is it the only solution to that differential equation? No. Give me another one.
X squared plus c.
Y equals x squared plus c, where c is any number in the world you want it to be. So again, the general solution would be y equals x squared plus c, where c is any number you want. All right, that equation that I wrote, y prime equals 2x, we would call that a first order differential equation. Why do you think it's called first order differential equation?
It's the first derivative.
It has a first derivative. Y prime equals 2x is a first order differential equation. So what do you think a second order differential equation looks like? It has a second derivative. So something like y double prime minus 4y equals 0 is a second order differential equation. When we had a first order differential equation, we basically came up with one solution, y equals x squared plus c. What do you think is going to happen for a second order differential equation? How many solutions do you think there'll be? 2. And if I gave you a third order differential equation? 3, so on and so forth. All right, so typical homework problem you're going to see, you're going to be given a differential equation, y double prime minus 4y equals 0. And you might be asked, is y equals, oh, I don't know. Anybody want to take a guess at what the answer to that differential equation might be? Is y equals 0 a solution? All right. Yes or no?
yeah.
Yes. Yes, it is. Why is y equals 0 a solution? Well, when you take the second derivative of 0, you get 0. So you plug in 0 there, you plug in 0 there. 0 equals 0. So yes, it is a solution. That one's called the trivial solution. Not a very interesting answer. But a correct answer. It was a correct answer to the question. All right, so let me rephrase my question. Does anybody have a guess for a non-trivial solution? I'll make a guess then. Is y equals sine of 2x a solution? I got a 50-50 chance of being right. Yes or no?
No.
No, why not?
Well, the sign, because just looking at like how the sign changes of the sign, it's you have negative sine something minus 4 sine, I think.
All right.
It wouldn't equal 0.
So what you're saying is you're taking the derivative, and the derivative of sine 2x is
Cosine.
cosine 2x
2.
times 2. And the second derivative is
Negative 4 sine. Cosine.
negative 4 sine of 2x. So if I plug those in, plug in the second derivative, I would have negative 4 sine of 2x minus 4 sine of 2x. Does that equal 0? No. So is sine of 2x a solution? No, it's not. So what is the answer? I didn't make a good guess. Anybody else got a good guess? Worst thing that can happen is the answer is no. Any good guesses?
Negative sine 2x.
What's that?
Negative sine 2x.
Negative sine 2x?
Would have the same problem.
I think you'd have the same problem, because if I had a negative sine 2x, that's a good guess though. If I had a negative sine 2x, when I took the derivative, I'd get a negative 2 cosine 2x. And then when I took the second derivative, I'd get a positive 4, wouldn't I? So then I would have a positive 4 sine 2x minus a negative 4 sine 2x. I don't think that would give me 0 either. I think it would give me 8 sine 2x. Good guess, but not right either.
Tangent, maybe?
Tangent, maybe.
Because it's secant goes to secant squared, and I think.
All right, well, let's find out. Tangent, just tangent x, or do you want, if I were going to do it, I think I would want tangent of 2x.
Yeah.
Because I want to balance out with this 4 over here, so I think I'd put a tangent 2x there. All right, so what's the derivative of tangent 2x?
Secant squared. Well, 2 secant squared.
Secant squared of 2x times 2. And then the second derivative. Going to have that 2. Then let's see, I've got to deal with this 2. This is the thing furthest outside. So that 2 comes down. I'm going to have secant of 2x times, then I got to take the derivative of secant. What's the derivative of secant? Secant 2x, tangent 2x. And then I got to multiply by the derivative of the inside. That's 2. Well, does it look promising? If I plug in that second derivative, subtract 4 times my original function, and we're going to get 0? No, I don't think so. Good guess. Also not correct. What about one of those hyperbolic functions?
Well, we could just leave
That's an interesting choice. Y double prime minus 4y equals 0. Y equals, which one of those hyperbolic functions do you want to try?
Sine 2x.
Hyperbolic sine of 2x. That's an exciting guess. We just studied those hyperbolic functions. Wouldn't it be interesting if that was an answer? Y prime is, what's the derivative of hyperbolic sine?
Hyperbolic cosine.
Hyperbolic cosine. So we're going to have hyperbolic cosine of 2x. Chain rule, we got to multiply by a 2. And then y double prime, what's the derivative of hyperbolic cosine?
Hyperbolic sine.
Hyperbolic sine. There's no little minus sign in there like there was with the sine and the cosine. So we're going to have hyperbolic sine of 2x. Then I need to multiply by a 2 again for my chain rule. That's a 4. And that one does work, doesn't it? We get 4 hyperbolic sine of 2x minus 4 hyperbolic sine of 2x equals 0. So there's one of the answers. That's correct. But we said we were supposed to have 2 answers.
Hyperbolic cosine.
The other answer is hyperbolic cosine of 2x. That's correct.
Wouldn't an E function also work?
Yeah.
Absolutely. Because you might remember these hyperbolic functions were defined in terms of e's. So I'm actually very happy you said hyperbolic because I wasn't even thinking of that. Because I was thinking the answer should be y equals e to the 2x. Because when I take the derivative, I get 2e to the 2x. And when I take the second derivative, I get 4e to the 2x. But remember, hyperbolic sine of 2x has an e to the 2x in it. What else does it have? What was our definition of hyperbolic sine? It was e to the x minus e to the negative x. So if e to the 2x is one of the answers, what do you think the other answer is? Y equals e to the negative 2x is the other answer that I was thinking of. And again, you can check it. Y prime equals negative 2e to the negative 2x. Y double prime is 4e to the 2x, negative 2x. Plug in that second derivative, plug in that original function, and check it. They do add up to 0. So that's kind of an interesting question. Because normally we say we have 2 solutions, and we do have 2 solutions, but we can write them in different ways. We can write our 2 solutions just in terms of the e to the x's, or we could write our 2 solutions in terms of hyperbolic functions. But you do come up with 2 solutions. Questions on that? All right, so the next big question is, if I give you differential equations, how do you solve them? For example, how do you solve, I'm just going to steal one out of the book here. Let's start with a real easy one. dy dx equals 10x to the 4th minus 2x cubed. So there's a differential equation. I use the symbol dy dx instead of the symbol y prime. How do you solve that? Any ideas?
Take the antiderivative.
Why do you want to take the antiderivative?
Because then you would have the original y function.
Because what do antiderivatives do to derivatives?
Cancel them
They
out.
cancel them out. Typically what we do, you wouldn't really have to write this, but typically what we do a process, if we can, called separating the variables. And we'll do more of this here in the near future. So typically, if you can, you want to try to get all the y's on one side and all the x's on the other. And that's called separating the variables. Sometimes you can do that, sometimes you can't. If you can separate the variables, those are usually the easiest type of equations. And then you're right, what you want to do is just integrate. When you integrate dy, you get y. And what's the integral of 10x to the 4th minus 2x cubed?
2x to the 5th minus 1/2 x to the 4th plus c.
Plus c. Yeah. And that's the type of differential equations you're going to see in this section. The type of equations you're going to see are equations that are separable. You'll be able to separate the variables, and then you should be able to integrate. So how do they get hard? Yeah, nobody ever said the integration is going to be easy, right? Let's see if we can find one that's a little harder. How about dy dx equals e to the x over 4 plus e to the x. Our answer is, we can separate our variables. I'm just going to write it right in the integral form. Y equals the integral of e to the x over 4 plus e to the x dx. And so really the only question is, how do you integrate this?
Make u equal
Make u equal e
e to the x.
to the x.
Or, I mean, for the whole bottom.
The whole bottom, I like that idea even a lot better. U equals e to the x would have helped, but u equals 4 plus e to the x helped a lot more. Because when I take du, what's the derivative of 4 plus e to the x? E to the x dx, which exactly matches our top, doesn't it? So this becomes the integral of 1 over u du. And the integral of 1 over u is natural log absolute value of u plus c. So a final answer looks like natural log absolute value 4 plus e to the x plus c. And actually, although I don't know that it's any less work to write, you don't really need absolute values on that one. Just regular old parentheses would work. How come you don't need absolute values on that one?
E to the x implies a positive function.
E to the x is always a positive function, and then when you add 4, it's even more positive, isn't it? So it's not wrong to have the absolute values there, but it's not wrong to leave them off either.
Would you reduce it and get rid of the e to the x because of the log or not?
Would I reduce it and get rid of the e to the x because of the log?
I don't think you can with that. You can't do it with there's more than one, right?
You can't do it because these are connected with addition. If it were ln 4 times e to the x, then I suppose I could use my properties of logs and write that as ln 4 plus ln of e to the x, and ln of e to the x would just be x. Unfortunately, on the inside, those are connected with an addition, so there's nothing you can do. There's no way to separate it out and clean it up. All right, one more of those. How about? We give you very many good hard ones here. Oh well. dy dx is x cosine x squared. Well, again, we separate and we integrate. Y equals the integral of x cosine x squared dx. What's your technique for integrating that one?
If you make x squared equal
If you let u equal x squared, du is 2x dx. So I need to sneak a 2 in right there. Balance it with 1/2. That becomes 1/2 integral cosine u du. And the integral of cosine u du is just sign. I hear votes for just sign, and I hear votes for negative sign.
Just sign.
Just regular old sign? No minus sign in front of the sign?
No minus.
No minus? All right. 1/2 sine u plus c. So it's 1/2 sine x squared plus c. Because the derivative of sine gives us cosine, so the integral of cosine gives us sine. There's no minus in that one. All right, the last thing I see in this section is they give you something like this. They say, here's your differential equation. X, y double prime plus y prime equals 0. And then they give you a general solution, and they claim the solution of this equation is y equals c1 plus c2 ln x. Why do you think that the solution to this differential equation has two constants? I mean, back up here when we did this problem, we integrated, we just did plus c. Why does this one have a c1 and a c2?
Second derivative,
Second derivative. When you have second derivative, what do you have to do?
have a constant going for first derivative.
You integrate once, you get a constant for your first derivative. You integrate again, you get a constant for your second derivative. So when you have a second order differential equation, you typically get two constants. And then they give you what are called initial conditions. They say when y equals 0, x equals 2. And when y prime equals a half, x equals 2. And the directions are two things. First, verify that the general solution satisfies the differential equation. And then part 2, find the particular solution that satisfies the initial conditions. Okay, so how do we first make sure that this equation really is a solution to this differential equation? It's easier than you think. Take the derivative, plug it in, take the second derivative, plug it in, and make sure it works. So I'm not asking you to actually solve this equation, I'm asking you to just check that this one really is an answer. So we'll take the derivative. Y prime is, what's the derivative of c1 plus c2 ln x?
C2 over x.
C2 over x, because the derivative of c1 is just a number, that's 0. The derivative of ln x is 1 over x. So what's y double prime?
Negative x to the negative 2.
Think of this as c2x to the negative 1. So you're going to bring the negative 1 down. You're going to have negative c2 x to the negative 2. And I might write that as negative c2 over x squared. Okay, so we take those two things and we plug them in and we make sure it works. We have x times negative c2 over x squared plus c2 over x. That's negative c2 over x plus c2 over x. It is indeed 0. So that equation that they gave us is indeed a solution to that differential equation. So that was the first part. And then the second part was find the particular solution that satisfies the equation. What are they asking you to do there?
Solve for C1 and C2.
They want you to figure out the values for C1 and C2. And how are you going to figure out the values for C1 and C2? Plug in this information that they gave you. Why did they give you two pieces of information? Because if you just did the one, you'd still have two unknowns. That's exactly right. So we've got to plug in both of these conditions to solve because we have two unknown variables. All right, so if I plug in the first condition, y equals 0, x equals 2, I'm just going to plug that into this original equation. I get 0 equals c1 plus c2 ln 2. And it's exactly what Charles said. If you only had one initial condition, you'd have one equation with two variables. Can't solve that. Plug in the other initial condition, y prime equals a half when x equals 2. So I go to my y prime formula here. I have 1/2 equals c2 over x. Oh, not c2 over x, c2 over 2. X is at number 2. All right, well, I can take that second equation and I can solve it. For C2, C2 is 1. Take that, plug it up into there, I get 0 equals C1 plus ln2, which tells me C1 is minus ln2. So the particular solution that they're looking for is y equals minus ln2 plus C2 was 1 ln x. Questions on that?